Assalamualaikum to Doctor, and my name is Muhammad Zakwan bin Zafi. So today me and my team going to present about the safety presentation for our production of methanol. So let's start.
Assalamualaikum, my name is Siti Nur Shuhada and I will presenting about the introduction of our company, the three processes that we choose, the differences of the processes, and the method that we choose in order to choose the best process. As we can see in these slides, this is our company's logo. Our company's name is MEO Co, which is stand for MEO stand for Methanol Company Limited. Methanol is a well-known toxic alcohol that was widely known in industry as a solvent, pesticide, and alternative fuel sources. It is highly flammable, volatile, and colorless. However, methanol is the best option for a fuel cell power vehicle as it produces at least twice the efficiency of an internal combustion engine. Methanol also can be found in human beings, animals, and plants. Methanol can be found in food such as fresh foods, fermented beverages, and diet soft drinks. However, the amount of methanol exists in food is at low level, so therefore it will not cause any fatalities to whoever consume it. Methanol also was known to be the building block to produce other components such as formaldehyde, acetic acid, gasoline, and different olefins. In wastewater industry, methanol was used in a small amount to delignification bacteria in order to convert nitrate to produce nitrogen. In conclusion, production of methanol is crucial in people's daily life, and it will not cause any harm to whoever utilize it. And methanol is widely known in industry to be used to produce pharmaceuticals, paints, and other stuff. So that is why our company decided to choose methanol as our product due to the high demand in the market. Now I will explain about the differences of these three processes, and as we can see in these slides, two-step methods and direct method has same fit and safety, which is in fit they have carbon dioxide and hydrogens, and in terms of safety they may have potential of detonation and fires, may cause explosion and crackings, and high concentration of carbon dioxide may cause suffocations. And for direct oxidation of methane, they only have methane as it fits. And in terms of safety, it may be extremely flammable and may form explosive and mixture with air. In terms of byproduct, two-step methods and direct oxidation of methane has the same byproduct, which is they have none byproduct at all, while direct method has water as its byproduct. And in terms of operating condition, two-step methods and direct oxidation of methane also has the same criteria, which is high pressure and high temperature, while direct method only have mild temperature and the pressure can be varies. In terms of selectivities, two-step methods can be up to 95%, while direct method can be up to 99.8%, and direct oxidation of methane can be up to 84.6%. So for two-step method and direct method, the process is completely non-complex compared to direct oxidation of methane. So now I will explain about the three processes that we choose in order to produce methanol. So as we can see in these slides, the equation for direct methods, the reactant was used is at the ratio of 1/3, which were 1 carbon dioxide mixed together with 3 molecules of hydrogens in order to produce methanol and water. At this process, catalyst is very crucial. A suitable catalyst is very crucial. So for this method, the catalyst that was used were copper or zinc oxide that is doped with zirconium dioxide in order to achieve the highest selectivities. So as for the second method, which is two-step methods, the first steps for the process is the reactions between carbon dioxide with 2 molecules of hydrogens in order to produce carbon monoxide and water. For the second steps, carbon monoxide will react together with 2 molecules of hydrogens to produce methanol. So for this process, the catalyst that was used was copper and zinc oxide. So for the last process, which is direct oxidations of methanes, the process that was used is cyclic process that was formed by methane adsorptions, methanol desorptions, and oxidative regenerations of the catalyst. Findings indicates that copper exchange morganite is the most suitable catalyst for this process, as it helps to achieve the highest yield towards methanol, which is screening methods. And on the left, we have weightage factor scoring model, which is also known as scoring method. These both methods shows that direct method is the best process as it has the highest score compared to two-step methods and direct oxidation of methane. So our company has decided to produce methanol by using direct method, as this is the best solution, the best process to produce methanol. So that's all from me. Thank you.
So in this slide, I'm going to talk about the piping and instrumentation diagram for the production of methanol by using direct method. First of all, carbon dioxide and hydrogen are used as the reactant with the ratio 1:3 and are fed to the reactor. Zinc oxide are used as the catalyst for the first and second reactor later. And then the stream coming from the first reactor are mostly carbon monoxide, diethyl methane, and methanol. And then the stream coming from the first reactor are mostly consist of non-reacted reactant and will lead to heat exchanger for it to cool down before are fed to the flash separator. The flash separator will separate the stream for two phases, which is liquid and gas. So the gas phase will be redirected to the first reactor, meanwhile the liquid phase will be led to the second reactor for additional methanol synthesis. At the same time, hydrogen is recovered by using pressure swing adsorption unit. And then the stream coming from the second reactor will be fed to the flash separator, the second flash separator, for it to separate between gas and liquid phase. The liquid phase is now consists of mostly water, and they will lead to the series of distillation column, and the final product from the distillation column will be methanol product and wastewater.
A very good day to our lecturer, and my name is Dila Michelle. For today I will be presenting my part, which is regarding the hazard and operability study, also known as HAZOP. For our first slide, anyway, here we're going to be talking about the reactor. Now reactor, there are three categories, which is I mean the three parameters. First parameter would be the flow, temperature, and pressure. Each parameter have its own deviation. For the parameter flow, the deviation would be no, less, and more. As for temperature and pressure, the deviation are the same, which is high and low. For the deviation no from the parameter flow, the causes would be that the feed line doesn't turn on and there's a leakage in the feed line. Now the consequences would be there will be no flow in the feed line into the reactor. Therefore, the action required would be to turn off the valve, fix the leakage, conduct regular maintenance, and also install no flow alarm. As for the deviation less, we need to rule out that there might be a possibility of the feed line containing impurities. Now, due to this, the reactor cannot fully function without the reactant fully enter the reactor. Therefore, we have to clear the impurities. As for more flow, it would mean that the control valve failed open. This would cause the reactor to be overflow. Therefore, the action required would be to turn off the valve when the reactant fill up the reactor up to a desired level. As for the temperature, there will be two deviations, which is high and low. As you can see in the slide, for the deviation low, there will have no consequences or no action required. This is because that the cooling system is working. And therefore, for high temperature, it would mean that the cooling system is not working. This would cause the process to undergo vaporization. Therefore, the consequences would be to install high temperature alarm. As for pressure, there's also two deviations, which is high and low. As for high, it would mean failure of pressure valve. Now, high pressure would cause the reactor tank to be ruptured, which in return we have to install high pressure alarm. As for low pressure, there would be a possible leakage on the pipeline. Now, this would cause of vacuum condition in the reactor. Therefore, we have to conduct regular maintenance. Since that in this PID, there are two reactors, and in this PID also, the both reactor applies the same hazard analysis due to it having the same process and same, same system. That's why. For the next slide, we'll be continuing on talking about flash drum. As you can see here, flash drum, there are two parameters, which is pressure and level, and each parameter have the same deviation, which is high and low. For the high pressure, they will mean that the temperature of the feed is high. Other than that would be possible blockage in the outlet stream. The consequences would be rupture of the flash separator tank. Other than that would be an increase in the amount of vapor in the tank. The action required would be to install high pressure alarm and conduct maintenance check. As for low pressure, it would mean that there will have possible leakage in the flash separator. Also, the temperature of feed is low. The consequences would be high amount of liquid in the tank and low amount of vapor recovered. Due to this, we have to install pressure indicator. For level, there are high and low. For high level, it will mean the amount of liquid is higher compared to vapor and the temperature of feed stream is low. The consequences would be no vaporization occur. Therefore, the action required would be to install temperature controller at the inlet stream. As for low level, it would mean that blockage in the inlet stream or temperature of the feed stream is high. Therefore, separation doesn't occur. The action required would be to install temperature controller and install low-level alarm and conduct maintenance check. As for installing temperature controller, we have to install it at the inlet stream instead. Other than that, the flash drum, there are 2 flash drums in the PID which have similar process. Therefore, both flash drum applies the same hazard analysis. For this slide, we'll be talking about distillation column. Distillation column, there are 3 parameters this time, which is the flow, level, and temperature. For the flow, similar with the reactor, the deviation would be no less and more. As for level and temperature, the deviation would be similar, which is high and low. Now, for the flow, it is also similar with reactor, where when there is no flow, it would possibly mean pipe blockage, or the control switch doesn't turn on, or the pump failure. As for less, it would also mean that pipe blockage, leakage at the pipeline, or pump failure. However, if there are more flow, it would mean that failure to switch off the control valve or the pumping capacity increases. The consequences would be for no flow, distillation process doesn't occur, and also there will be no flow in the column. As for less flow, the product produced would be having a different concentration than the one that we desire, and they would have also less flow in the column. As for more flow in the distillation column would cause flooding, and this can also change the product quality, which is why for no flow we have to install a low level alarm, and of course to conduct maintenance check, and also to install to emergency plant shutdown. As for less flow would be to install low level alarm, install bypass, and also as usual conduct maintenance check. For more flow, it would be better to install a high level alarm. Next, for our level parameter, for high level, it would be causes by outlet stream valve is closed or the blockage at the outlet stream pipe. As for low level, it would possibly mean there would be a leakage at the pipeline. Now, the consequences for high level, it would cause overpressure at the reflux drum, and it could also produce liquid backflow into the column, which is why the action required would be to install high level alarm and of course conduct regular maintenance check. As for low level, it would be best to install low level alarm and conduct regular check, because the consequences would be the product produced doesn't meet the requirement. As for temperature, the high temperature would mean failure of cooling system, and it would cause overpressure and may rupture the tank, and therefore we have to install high temperature alarm and build a backup cooling system. As for low temperature, it would be caused by failure of the heat exchanger system, which is why it would cause also changes in yield of the product, and it is required to install low level alarm and conduct regular maintenance. In this PID also, there are 3 distillation column, applies the same hazard analysis because they have the same process. As for my last part, which is on heat exchanger, the parameter applied would be flow, pressure, and contamination. For flow, similar with the others, there would be possible blockage in the pipeline if there are no flow and also no cooling water flow in. Other than that, the consequences would be failure of cooling down the fluid temperature. The action required would be to install temperature indicator and install high temperature alarm. As for less flow, the causes would be leakage at the pipeline, and the consequences would be less flow of cooling water and the fluid temperature is not lowered accordingly. Therefore, the action required would be to install flow meter. As for more flow, the causes would be failure of closing control valve, and therefore the consequences would be overflow of cooling water, temperature of the outlet fluid is too low, and the action required would be to install low temperature alarm and install temperature indicator. For pressure, we only have one deviation, which is high. Now this would mean causes by failure of cooling system. Failure of cooling system would means that the temperature is not cooled down accordingly, and it would increase the pressure. So the consequences would be possible rupture of the heat exchanger. The action required in this case is to install high pressure alarm. As for contamination, the deviation would be corrosion of the tube, and corrosion of the tube would cause the hardness of cooling water to happen. Now the consequences would be cracks in the heat exchanger and of course produce less cooling water than needed, which is why the action required would be to conduct regular maintenance check. Now in this PID, again, there are 4. Including this one, there are 4 heat exchanger, which applies the same hazard analysis as well, since that it undergoes the same process. And that's all from me. Thank you very much.
Assalamualaikum and have a good day to our lecturer. I am Nadia Shakira Muhammad Nahar. In this video, I'm going to explain roughly about fault tree analysis, or known as FTA, that we construct based on the process method that we have chosen. Fault tree analysis is a graphical diagram to study the causes of device level failure. Generally, FTA consists of 2 main elements, which are event symbols and get symbols. Event symbols subsist into top events and basic events. Top event describe the critical system, meanwhile basic event indicates the cause of the failure. Get symbol used in basic FTA are AND gate, meaning the failure occurs when all the causes occurs, and OR gate, meaning the failure occurs when at least one of the causes occur. To further explain, let's take a look at the direct oxidation of methane method below. Our concern here in this method is production system failure. So here beside me is the fault tree analysis that we have constructed. To illustrate my point, let's take a look at the causes of production system failure one by one. As you can see on the slide, since the gate used for storage tank failure is OR gate, means that either leaking or overfilling occur is enough to cause failure on storage tank. Leaking and overfilling here, as we can observe, use intermediate event symbol, which is rectangle, means that there are still another pathway below them that indicate the problems that can cause them to occur. Taking leaking as an example that use AND gate, meaning here is if both pipeline system rupture and operator failure happen, only then leaking can occur. Okay, why? Because if the pipeline's having problems, the operator can change the system to manual and fix the broken pipelines. But if the operator fails to control the situation, there will be issues rise on the storage tank. Indicating the change of shape used in causes of leaking, we will notice that the shape used is circle. Here means this is the end of the pathway. Moving on to another problem that could arise during the production of methane, as shown in the slide here, we can observe that one of these two can cause distillation column malfunction. In spite of the fact that blockage at inlet or outlet itself can cause the distillation column malfunction. Hence, the OR gate is suitable to be used here. Moving on to another problem that could arise during the production of methane, as shown in the slide here, we can observe that one of these two can cause distillation column malfunction. In spite of the fact that blockage at inlet or outlet itself can cause the distillation column malfunction. Hence, the OR gate is suitable to be used here. Okay, next cause is pump failure. It can have chances to happen if either cavitation or pressure inlet inside the pump is low, or there is excess vibration inside the pump, or if all three causes occur. I would like to give a clear vision here for cavitation here. It means that there is the formation of vapor bubbles in a moving fluid, causing the pump to operate outside of their specific range. The following slide is another example of production system failure causes. We notice that heat exchanger have the same kind of pathway as distillation column that I have explained before. It becomes apparent that if one of all these causes happen, is enough to lead in heat exchanger malfunction. A little bit explanation on this part. Pitting of tips here means there are maybe a few pinholes formed on the tube, causing fails and leaking to occur due to the chemical corrosion. Meanwhile, for the thermal fatigue, here means that the tube are cracked due to the extreme temperature difference between shell and tube. Last but not least, problems in compressor 2 can affect the production system. Here goes why. We aware that if the voltage supplied to the compressor is low, it will automatically result in compressor failure. Okay, next, low in lubricant level also can give rise to a number of serious issues regarding compressor failure. Just as the compressor is the heart of our production system, the lubricant is the blood for the compressor. I hope my explanation is enough to describe the Vautrin analysis of direct oxidation methane method. Thank you.
So after we have done with the Herzog and Herath analysis, we have made some major changes to the component in the PNID, such as the reactor, distillation column, flash drum, and heat exchanger, for it have a better safety precaution. So now let's start with the reactor. For the reactor, we made some changes, such as we added a valve. We also added pressure alarm high, temperature alarm high, because we don't want the reactor have a low liquid level, which will increase the temperature and probably will cause major injury and harm to the surrounding. So this also applies to both reactor N, reactor 1 and reactor 2. For the flash drum, we add valve and pressure alarm high, liquid alarm low for the both flash drum, so it will prevent the flash drum having low liquid level. Thus will increase the pressure, and the component inside the flash drum will have a low separation efficiency, which will cause the purity of the product. For distillation column, we add valve, temperature alarm high, temperature alarm low, liquid alarm high, liquid alarm low, so that this parameter will maintain and the separation between methanol and water will be more efficient. On the other side, we also added a jacketed cooling to the distillation column to prevent the distillation column from overheating as a result from low liquid level. The jacketed cooling will be filled with water that came from cooling water, and this also implies for the three distillation column, the first, second and third distillation column. So for the heat exchanger, we add a valve, pressure indicator, temperature indicator to the heat exchanger. So the pressure indicator will be maintained at optimum process condition before it led to the flash separator or reactor, and this will apply to the 4 heat exchanger as well. So in this slide, this is the final and improved piping and instrumentation diagram for the production of methanol by using direct method. So there are major changes made to the reactor, distillation column, flash separator and heat exchanger after we have done the absorb and heat analysis. The absorb and heat analysis will help in the safety precaution for this equipment, so it will be safer and less harmful to human and to the surrounding. So this is the end of the slide. Thank you.